So we're starting to see some interesting things happen in the realm of media creation. I think everyone's been paying attention to image generation, probably if you're in the space for the last almost 2 years now. But we're really starting to see some advancements in video production that are really exciting. This notion of keyframes and the way that keyframes worked in Flash was you would do an animation in different parts and pieces, and Flash would kind of just like interpolate all of the animation pieces. What we're starting to see happen with 3D and AI models is that you're using an image to help serve as a keyframe in order for the video model or 3D model to kind of figure out what goes in between. And so what we're going to talk about today is both that concept of keyframing and how we can get very intentional about composition of an individual keyframe, but we're also going to talk a little bit more about some of the developments in the tooling that supports keyframing. There are new tools essentially in the SDXL toolkit that make for some fun experimentation and new ways of controlling the AI generation process. So that's what we're going to talk about today: control and composing keyframes. So I've got this very sad guy here. You know, he's kind of like later in life. He looks like maybe he's thinking about some decisions that he made that he no longer feels good about. He's just very down. You know, this is something that I think, you know, what happened that led to this moment? What would be an interesting moment for us to have a transition from in a video? And so, you know, what I think I'm going to do here is I'm going to go to our control layers. I'm going to open up the new depth model that was released. Now, we've had depth models before, so depth isn't exactly entirely new, but this is a new model. And so this is going to kind of be one of the first tests of how this model functions for us, what we find in using it. It's literally something that I saw this morning, so I haven't played around with it yet. And we're going to see what it does. But this is a tool in the toolkit, and we'll play around with it here. So first thing we're going to do is just use the depth processor to get that kind of 3D layer there. And then we are going to do young man sitting on a bench. What else do we want to do? We'll do some film stuff, 80mm lens, cinematic films build, high detail. Yeah, we'll try that. Crisp. Okay, we'll get that generating and see what we get. So what I'm doing is I'm using the same composition, but I'm trying to like maybe get a younger version of this guy back when he was a young man. Obviously, this is got the same tree, maybe the same bench. It looks somewhat similar, maybe not super similar. So we've got, you know, some similar elements in the background. And the question that I'm asking right now is, would this transition look good? Well, I'm going to answer my own question. I'm going to say, I don't think that these serve as good keyframes. What would happen if I use these both as keyframes? Well, everything here would change. So we would see this tree probably stay roughly the same. There'd be some changing here on the bench. Maybe it would look okay, but it looks like a different material almost. And so that's kind of something that I want to fix. But the other piece is this building in the background is maybe not exactly what I'm going for here. So now I'm asking myself, how could I get more of what I am looking for and less of those things that are changing that I don't want to change? And that is a good question that I need to ponder over now. I will remind you that the chat is open, so if you've got questions while I'm going through this, don't hesitate to stop me. But I am just going to probably start talking through this and figuring out how I might do what I'm looking to do. Someone said he's sad because the building was built. Perhaps it took down his favorite building for an apartment complex. Maybe it's almost like a university in the background, very open space. Now it's maybe some apartment building. This isn't too bad. It's still the same like pose, but it just doesn't have the same background, and that's like the big issue that I've got right now. So maybe I'm going to play around with this a little bit. Maybe I'm going to play around with this. I am going to send this old guy to the unified canvas, and I'm going to erase. What am I doing? Am I a crazy madman? Yeah, maybe. I'm going to erase the head and hands. Erase the head and hands. Get my control adapter from the other one. We'll erase that too. Bear with me. This is not the final step in the process. It's just one step. I'm going to take this control layer. I saved it by hitting that small floppy disk. And I'm going to age myself there in case there are any like children in the audience. But a floppy disk is how we used to save information on physical media back in the 90s. It's great. Before the 90s too, but I'm a 90s kid. So we're gonna hit that floppy disk to save it. We've got our control image over here on the right. And we are going to the canvas. We're gonna take that control image that we've got and use the same model here. And we're gonna say young man sitting on a bench. We'll go ahead and generate, see what we get. So what I've done is I kind of like erased the parts that I wanted to fill in. It's going to use colors from the existing image to infill that. And then it's going to keep everything else the same. So we'll keep all of that other stuff good. Now it's maybe looks a little bit like it's not going to fit perfectly. We might need to fix some details here. That's okay. Again, this is not the final thing. So we're going to go in, turn off our control, and maybe just fix this face a little bit because the details are a little funky. They're a little funky. It's not really happy though, is he? I'm doing this. A young man sitting on a bench. Happy. He's like young and happy. And maybe do some of this head. Well, take out sitting on a bench, just make it easier. Kind of hunched a little bit. We're not going to get too. Oh yeah, there's the happy smile. Okay. Now, yeah, that head's a little bit small. It's my only complaint about that. So maybe what I'm going to do is just regenerate that top half, because again, I'm not making the final edits here. I'm just creating something that I'm going to use as a tool momentarily. Okay, that's all right. We'll take that. He's a little slouched still. Face is a little bit better, and we're okay with that. I mean, does look relatively happy. Does look happy. Someone said we're remaking Back to the Future in Invoke. That's fun. Okay, so now we've got like our younger guy. What I want to do now, though, so I'm going back to here. I'm going to save out this image. And I'm going to turn on tile, the new tile ControlNet. And we're going to use this as a tile control. And what I'm going to do is I'm going to turn this down just a little bit. What that's going to do is it's going to keep a lot of the details the same, but it's going to give the AI an opportunity to kind of like reimagine some elements a little bit. It's kind of like almost like a remix of sorts. When you turn down the weight on the control, it allows the prompt to come into that. So we'll see what we get at 0.5 and play around from there. We might see that it's a little bit too low. It might be perfectly perfect. Okay, it kind of looks like an old photo. Maybe that's what we should do. Vintage, old photo. Gonna push it more towards that. It's starting to get there a little bit. Maybe I'll taper off on the end as well so that it kind of applies that early on and then frees it up a little bit towards the end. And again, restating what those two controls that I messed around with do, you can think of it over the period of the generation process, 0 to 100. Do we want the control applied? And that's what the beginning and end step dictates, is where is the control applied? And then the wait is how much is it applied during each of those steps. So we've got our future, past, probably could go in and fill in some details, but generally looks pretty good, right? Like we've got a lot of the same details there. He's wearing the same jacket in a different era, or a different color jacket, sitting in the same spot. So if we were to use these as keyframes, we would kind of see the start and the end, and it would do some weird aging transformation in the video generation model. We're not going to play around with it right now as far as like going into Luma and playing with that, because I have a feeling we would get distracted pretty quickly making memes. But you get the idea of like keyframes and how you might create things. Now, if we wanted to, for example, create one that was really just a different scene. So this one's kind of more of like a transformation scene, young to old. If we wanted to create one that was him moving out of the shot, for example, we might do something like erasing this guy out completely. So we'll just erase that. Little by little. And then turn this to an empty park bench. And let that fill it in. And what that's going to do again is, if we were to use this as keyframes, we could either have it be empty bench as the start, old guy as the end, and the video generation model would have somebody come into the shot, sit down, and they would be there. Inversely, we could have him start on the bench and then turn it to nothing and then go from there. We've got like a broken park bench that we're going to need to fix here. It's like a... we use this as the end step. Maybe he like blasts off from the bench and it kind of like ruptures underneath them. So we could, you know, save this one out if we wanted to use that as the keyframe. But what we'll do is we'll fix this one. So what we want to do is kind of make sure that it connects. And so we'll just fill those pieces in there. Put this guy down here. There. Just regenerate all of that in the middle. Just make it a little bit more seamless here. It didn't have too much of the denoising strength very high, which is probably part of the problem. We're getting a little bit of funkiness over on the right. Okay, we'll get that fixed. There. And fix up some of those details. So again, all we're doing is kind of creating these scenes that have different parts and pieces. I'll do a couple generations here just so that we can get one that has it all the way extended. And our goal in this process is finding a way to minimize the amount of difference in the areas that we don't want to change and maximize kind of like, you know, the empty spots that were there before, different angles of characters, so on and so forth. I will call out, this would be just a lot easier if we could composite the old image back on top of this so that we're not even fiddling with those parts on the side and regenerating them. And that's in the progress, so you'll be able to do that soon. In the meantime, what I would do is probably just do something like it's connected there. emphasize those details. And up a notch. It's not enough. But again, I think the easiest way would be compositing this back over. And we'll call that good once it's done. So I'm sure I could fiddle with that all day. Details. So you get the idea. We've got our in frames. I need to save out that one. We've got our start and our in frame. We've got our start and our younger versions of the character, so it could transform just those pieces. We also have one where, you know, he's on the bench and then he explodes, right? And the video model would kind of like interpolate those and try to figure out how, with your prompt, those things connect. And that's really the interesting part about what's happening with media creation is we're figuring out how to get control over different parts and pieces of this in this very distributed way, where some teams are working on image like Invoke, some teams are working on video and controlling kind of more of the video control techniques, like Runway has motion brushes and things like that. And Luma's introduction of keyframes, I think, is going to be very much something that we see the other AI models go after, which is really how do we provide a start and an end and connect these two pieces. Now, I do think that it's useful to think of keyframes also as just start only. So you put in a start image and let it kind of evolve from there. That allows you to get all the same power of like character consistency and so on and so forth in just different shots and just extend those using the video model, which we've seen with, you know, early tools. But I think, you know, we're starting to see the evolution of those, and having both ends and both keyframes is really an interesting piece. So the other model that I think is interesting to play around with is going to be the tile ControlNet. And we kind of started playing around with that a little bit here. I had a chance to test this out earlier, and I'll kind of show you what I discovered. But I've got this picture of kind of green marbles here as my initial image. And if I write red marbles and use the tile ControlNet even at 1, what I discovered is that that is actually formulating a lot of what's inside of the image. In this case, it made them blue. I'm not sure why. Maybe it interpreted that as like purple or something like that. Previously, when I had tested this, I actually wrote blue, but maybe it's just biased towards blue in general. But if I type green marbles, it produces green marbles pretty well. That's an interesting discovery. For some reason, it doesn't want to do red. Maybe it's like the color channels are a little bit weird in its interpretation. So it'll do green. It's really strange how that is working for the red, though. If we can compare this to the original image, you can see that in the blue version here, there are a lot of similarities, but it's not one-to-one perfect, right? It reformulated some pieces. There's a lot of the same lines and cracks, but there are different areas of light in the marbles and reflections. There's the general patterns and shapes, but I think this is a way to think about the tile model. It is not a one-to-one for pixel content, or at least this version of tile for SDXL is not. Instead, it is almost kind of like a light bias, light and structure bias, rather than firm color bias. Tile is often used in upscaling. Someone asked that question, is tile an upscaling model? Tile's not an upscaling model necessarily. It is a control model that is used during upscaling. Very often, the way that upscaling works is you take let's say a picture that's 512 by 512, And what the tiled node does, we could talk about the tiled node, as that's a recent feature in 4.2.5, I believe. But what it does when you're upscaling using the tiles, it breaks the image into small tiles and then makes those bigger, right? It makes those 1024 by 1024. And by using tile, you're able to get a lot of consistency with the smaller image in the larger image. It's almost like a different way of doing an IP adapter composition only, right? It's looking at the composition, but it's structurally rather than semantically controlling that process of creating the image. And so I'll break that down because I know those are somewhat complicated terms. When I say structurally, I mean that it is looking at the with ControlNets, when you're using something like a tile or canny, it has trained and learned that certain pixel data creates certain structures in the image, and it is replicating those structures using the actual visual information. It's saying this pixel here is pretty bright and this one's dark. I'm going to kind of enforce that structure here. Or this is an edge. I'm going to enforce that structure here. And it kind of works backwards from, if this structure is true, what must this image be? Like, where are the things in the image? That's how control nets work. With IP adapters, when you're passing an image in, it is passing that image first through a model that looks at the image and says, what's inside of this image? And it outputs that kind of like math soup of what is inside this image. What do I think it is as an AI model? What do I think it is? Or how would I describe how things are placed? And it is then passing that information into the model. So it's not so much the same type of control, but you can use it to get the same output, which is the same composition, right? The tile control net does this by, again, looking very much at the pixel data. And so in upscaling, it's very useful to make sure that all of the lines match. It's almost like one of those puzzles or art techniques where you do art on a grid and you kind of like, map different squares to different squares. That's how the tile control net upscales it. So it's a really interesting tool. I've got a couple questions coming in that I'll try to answer. What are the main differences between composition, IP adapter, and tile? Maybe I just did answer that. Hopefully I answered that question. But composition IP adapter is really more like composition vibes, right? Like it's almost like playing telephone. You pass an image in, you see what the AI model says, and then the AI model tells the other AI model what to go make. It's kind of like an interpretation of the composition. Whereas tile is very much controlling structurally where things are going to be using that kind of like control capability. So it's kind of making the lines or the highlights, and the AI model is kind of working backwards from those. Hopefully that explains it. Maybe we can use this as an example. So this is tile, right? We'll delete the control net and I'll use IP adapter here. We'll start with just the base IP adapter for SDXL, which again, I always use VITH. Reason why it has more letters. And we'll use our kind of marbles image here and draw that in. I'm going to keep the weight at 1, and I'm going to say, give us green marbles, right? And what we're going to see is that there's roughly the same marbles in the same spot, but it is not going to have, maybe not even, right? It's like, it's looking at the image and it's like, there's a bunch of marbles here, but structurally very different, right? So if we're looking at this and comparing to this versus our original image, it's the wrong page. So we've got our original image here, and we'll look at our, tile. Very much, this is where the thing is. This is exactly where stuff is. Yes, there's going to be a little bit of tweaking because the AI model has regenerated the entire thing, so it's not one-to-one exact, but very much structurally similar. Versus Vibes, composition vibes. When I look at this picture and I'm describing, it's like, you know, you play one of those games. I'm trying to remember the one where you like describe it to the other person, they have to draw it. Uh, anyways, one of those games. Pictionary, maybe it's Pictionary. I think Pictionary might be the other way though. As I draw it, you try to describe it. Either way, uh, you're passing the picture in. It's creating a semantic interpretation of that, and it is then passing that on as conditioning. And so in this case, the AI model is looking at this and like, imagine you didn't see this, and I'm just describing it to you. There's a bunch of circles. They're, you know, all super close to the screen. They're positioned on top of each other. There's just, it's like a big pile of marbles. They're all green. You know, I would say that probably is a relatively decent interpretation of that just random description being generated, right? As I'm showing you the picture and it generates that. And so that's one of the big differences. Again, this is the base model for IP adapter. And I wanted to show that because this is the strength of interpretation that you get with base IP adapter. And this is both for style and composition. It's kind of like loose vibes. When you up this to plus, we're going to see it is going to have significantly more adherence to the original composition, right? I would anticipate a pretty significant change and more similarities between the two. Yeah, so we've got versus our original, I would say much more similarity structurally, right? It is, there's some big ones and small ones rather than just like a bunch of small ones. These almost look like paintballs. This one, there's much closer adherence, but it is still not like structurally the exact same. Now, maybe I like this aesthetic, but I don't like the fact that it's not the same shapes as my original. How might I get both of those? And so I'm going to add another control adapter here, but I'm just going to use maybe depth. So we'll use the new depth model. I'm going to pass that in as a depth control, and that is going to actually look at the structure here. Let's do a quick comparison. Be interesting. I think roughly looks pretty good. You know, it captures most of the orbs here. So we'll give that a shot. I think that's reasonable. So again, we're doing, I mean, we probably don't need the IP adapter for composition on this. So maybe I'll just turn that off. And we'll just get what we see when we're actually using just the depth control. So again, we're talking a lot about compositional control right now, and it's pretty important when you talk about, you know, keyframes. This one's using depth. We've used tile, and we've also used IP adapters composition. So this one looks much worse quality-wise. I'm wondering though, I'm going to try a different depth model. I'm going to try the old depth model. So the one I just did right here is the new one that was released today. We're going to try the old depth model. See how that changes things. I would say it doesn't make it that much better. It's roughly, I would say, worse. The best one out of all of these in my mind is probably, like, aesthetic wise, is probably IP adapters composition only mode. This one is obviously the most accurate tile, but I'm generating the exact same image, right? And so I'm not really like inspiring it so much as, yeah, I'm not really inspiring it so much as just like nudging it in that direction. Now, somebody's made the suggestion, which I think is a good thing to try as well. And this is probably maybe a more exploration of how do I get control over this and like what tools are in my toolkit. Somebody proposed using IP adapter plus Canny. And so we'll do IP adapter. We'll go back to plus. We'll go back to composition only, and we'll put this one back in. And then we'll use control adapter in addition to that. And we'll use the same image. Let's see what that gives us. I think that'll do, but let's maybe up the threshold here. No, I want to bring that down. I want to get some more. Don't want to get too much of this kind of like inner marble light. I think it'll make things weird. I just want to get the majority of the shapes. Okay, so we'll try that one. And I anticipate that this will bring more of the edges in. It might, I would say very likely will still have some of the coloring, but in this case, I think we're seeing that internal. So if we look at this versus this, what's confusing it is this internal gunk, right? So we're getting a lot of this kind of internal stuff that's changing the type of image that this is going to be. So let's turn this up and see if we can maybe just loosen this and generate it a little bit with less edges. Someone said maybe you use a different processor. I think that's probably worthwhile too. The other thing is I don't think we're not trying a fixed seed here, so there's a lot of stuff that's varying between this. Let's do that. Let's use a fixed seed just to see if that's driving some of the changes. I doubt it. It's possible. This one's not too bad. It's definitely green marbles, right? Let's compare the structure here. I mean, it is functionally generating the same shapes. Maybe we like this style, but we're trying to get it to use this shape. In that case, we might use IP adapter with style and pull that in. Let's see what we get with that. That's more like it. Okay, so walking back here, we've got our canny ControlNet, which uses the edges inside of the image to control structure. So it's basically whatever style, whatever lighting you want, but here are the edges. Now, you can, as we saw with this one, if you have too many edges, there's a lot of noise inside of it. There's a bunch of little squiggles. The AI model's basically working back from that and saying, okay, well, if there's that many lines, the lighting's got to be weird, right? There's got to be all of these weird shadows. Like that's the only way I can imagine why those lines would be there, right? And so that can kind of impose some really strange aesthetics. And that's why we brought the thresholds up here and made some of those edges go away so that it has a little bit more freedom to work with. And we really are just aiming for those outlines. Another technique that we've talked about in the past that you can do is you can save this control image out and you can take this to the canvas and edit that control image. You can go in and tweak it. And so some of the noise there that maybe we don't want, we want to keep the threshold low to get all of the edges, but we don't want all of the details inside. We can like jump into that and edit it in the canvas, putting black where we don't want the edge. And that's a really useful tool for then bringing back in as a control image. You turn the processor off by hitting the X button, and then you'd use that as your canny control. And that's another way we can do that. But when we turned it down, we added the style image here, and we had the composition image from this. I'm going to try one thing. I'm going to see what happens when we turn composition off and just keep the canny and style, because it's possible we don't need that compositional control from the IP adapter. If you mix IP adapters together, they do have a little bit of like an influence on each other, so it can be conflicting. But in this case, I mean, it really didn't change too much taking off that second IP adapter. We might try this with plus. So we did style without plus before. Now we're doing it with plus, all of this being a fixed seed. And that might get us a little bit closer to that style. Yeah. So we got this style, this composition. We go back and compare that to our original. I think we nailed getting what we wanted to out of this. Structurally, at least. So now we've got a better starting image. That was fun. We went through a ton in like a pretty quick amount of time. Recapping, we used just the new depth and old depth control nets. New depth is certainly better here, although I'm seeing these patterns that I don't really love, which includes like a little bit of like fuzziness. So might need some experimentation to figure out how to work around that with the new models. This was with Canny, and that's when we had the threshold pretty low and it had a bunch of lines in it. We increased that up, and then, you know, now we've got a little bit more of the structure without as much of the crazy lights. And then we played around adding in style and composition IP adapters with that. So this one I think is pretty good as our kind of like final marble image. And what you could do is use, going back to the keyframes concept, we might use this as a start and this as an end. And what we would see is probably like marbles falling, and it would be like just a river of marbles falling and rotating around. And so we've got two images of marbles, using that as a start and an end. The video model is going to kind of like fill in the gaps, and they're moving around somehow. That motion would probably be what you describe using the prompt in one of those tools. So it's really an interesting exploration there. Somebody asked if there is a tiled upscale workflow for XL. We just released the tiled upscale node, and so maybe that's something that we explore here as an interesting starting point. So maybe what I will do is load the workflow from our generation here. We're going to take out the IP adapter, keep our control net, and we will use our marbles image that we just created. Really like those marbles. And that would be the beginning of what we use to upscale this. So let's see. I'm going to have to do some reworking here, but I'm just figuring out where I'm going to do that. I'm just going to take out the core metadata node because it's just noise for this at the moment. So the first thing that I'm going to do is add tiled multi-diffusion denoise latents. Okay, so denoise latents, you generate one picture. Tiled multi-diffusion denoise latents uses tiled multi-diffusion to create a larger image by going through and doing a tiled control process. And so that has some different components. It interprets the components differently because it's specifically for the purpose of this. Somebody's noting that they were surprised to see that you can load workflows from an image. Any image you generate on the generation tab, if you right click and hit load workflow, it'll pop that into the workflow editor. So it's a great way to get started with more complicated workflows because you can figure out some testing on the generation tab and then load that workflow and expand it however you want to see fit. So it's a great place to start if you're doing anything like that. In this case, though, we're going to take our connections here, SDXL prompt, and take out that collect. Just connect conditioning. I'll take that conditioning and put that there. Probably need to increase our noise here, but that's okay. End up getting connected to latents. We don't want that. We will want a image primitive. Actually, we probably don't need that. We'll just do image to latents. Because using the tiled multi-diffusion process, you want to pass in an initial image, and that again is done by passing in the image through the latents node connection. So all of this denoising process happens in latent form, and so you're passing in your initial image by converting that to latents. So that this is the same as going into the generation tab and selecting a global initial image. That's what we're doing in node form. So we're going to pass in our green marbles there, the same ones. Probably should make those the same ones as we're using for our ControlNet or tile ControlNet. And then we are going to maybe set our tile ControlNet to 0.6. We're going to do our image to latents here and pass that into the latents channel. That's the wrong one. Here. Take our UNet, move that down. Take our control, move that down. Delete that guy. Connect our latents out. And I think we are good to go for this. We got 1024 tile height, which is what we want. I'll maybe do 64 tile overlap. Increase my steps to 30 and change my denoising start to point. Denoising start for the tiled upscaling is going to be kind of like your creativity slider. So if you want that to be lower creativity, you want that to be kind of a higher start. And so we'll do 0.7. This is a good starting point. And then we're going to not use Euler as a scheduler because Euler, it typically results in softer outputs. For this, I'll try UniPC. That one typically works pretty well for this process. And then we just need to change this to, how big do we want to go here? Well, we've got a non-square image, and we probably want to resize this first before passing it into latents. So we're going to do an ESRGAN upscale. My ESRGAN node. Need to do that as an image before it gets passed in as latents. So that, and then pass that image into latents, and then pass those latents into our tiled multi-diffusion. I'm going to let people ask me questions if you're not following along. Some of this is like just using workflows, but I know there's a lot of folks who might be new to the workflows concept. So if you need me to break down anything, let me know. But as somebody in the audience is calling out, I have to increase my noise and latent size first, and that's kind of what I'm doing here, right? So I've got my image, I'm upscaling that using real ESRGAN, which is just an upscaling model. These upscalers produce larger images, but the details are often a little off. And so that's why we're using it in conjunction with tile, because what it's going to do is it's going to take a lot of the structure from the original image, the light, the color, it's going to impose that, and it's going to regenerate that detail into the larger output. And that's basically what makes it super useful. So we'll do, for now, 4x. We'll take the width and the height and make that our noise size. And then we are going to pass that all in here. I think we've got it all. Some abandoned nodes that I'll delete. ControlNet's going in. We've got our model up here. Prompt is in. You can do this without a prompt. It's probably what I'm going to do is I'm just going to let it do its thing. And what am I forgetting? One image to latency is missing a VAE. Take this VAE and connect it. We're good to go. We're going to give it a shot. I'm sure I'm forgetting something. Invalid collector node. Take that. and we're going to see what we get. So if we look at the progress image, one nice thing with the tiled node is that it's going to actually show us the progress. This is another piece. This is another piece that I forgot, which I'm going to have to probably restart some things for because I just overloaded my GPU. Happens every time, doesn't it? When you're running this, hopefully you all can still hear me. When you're running this, you need to make sure that the tiled setting is on. If the tiled setting is not on, you're going to run out of memory. And that is what's happened here. So I'm going to restart the back end so that I free up my memory. Always fun to do that. And hopefully, yeah, we're back. Okay. When I restarted it stopped choking. If you don't have tiled on when you run this and the image is large, if you do something like 4x, if I'd done 2x, it probably would be fine. But the same reason that you can't generate an image that's too large all in one go with just doing any generation is because you'll spike the VRAM on the VAE side. So anytime it's going that big, you really need that to be in a tiled mode. Otherwise, the system's just going to say, not good, won't do it. You can solve for that by doing it in 2x, only 2x, so 2048 by 2048, or you can set that tiled mode and you'll be good to go there. So we'll set that to tiled. It's still back up at 4x, and then we'll generate. Now, there are some things that we've noticed. This node is still in beta. We've noticed some things with the tiled VAE that can cause some inconsistencies in colors across the tiles. Again, what did I set wrong this time? I didn't set tiled on image to latents, so it didn't create the image in the first place. Okay, try that one more time. Tiled VAE, it's the lesson of today. 4x is a big ask for image to latents and latents to image, and that's why you have to use tiled. What tiled VAE does is it does that process in chunks. It kind of does the same thing the tiled denoising is going to do, but at the VAE level. It kind of goes in and converts that into latent form at a lower resolution. And so in the progress image for this, we're actually going to see all of those tiles get updated each iteration. So we can actually preview the upscale as it's happening, which is pretty cool. It does take a little bit longer because it's effectively doing this for every single tile. So it's going through and doing 1024, 1024, 1024, 1024. So for SDXL, depending on the number of tiles you're generating, if it normally takes you, let's say, 10 seconds to generate an SDXL image, then it's going to take you that times however many tiles there are in the upscale to complete. And so that's why it took us about 40-ish seconds, maybe even a little bit more, because we're 4xing this. And so the number of tiles there is, I think, actually 16 tiles maybe. So it takes a little bit more time. But now we've got our upscaled version of the image. We can do the comparison here. And we can see that upscale produce the pretty accurate larger version of the image, at least structurally all the way down. There's even a little bit of detail that's been probably added in. So now we've got a nice larger image. I will say that while you can use XL for upscaling, this node works with SD 1.5, and SD 1.5 is the traditional way, I would say, of doing tiled upscaling. The main reason for that is it can just punch through a bunch of small tiles relatively quickly, and all of that works just as well in packing in detail, as long as you've got the right model and you just kind of want the exact same thing. One thing I will call out, if you are trying to do some amount of transformation, so you're trying to change the style, you're doing like a style transfer and then upscaling, you're obviously going to want to decrease the strength. You're going to want to maybe reduce the weight of the tile. But you're also going to want to make sure that the tile model, or the model that you're using for upscaling, is good in the domain that you're working in. So if you're wanting a photorealistic upscale, then you want to use a photorealistic model that produces really good detail and photorealism. If you're wanting to upscale art, you want a model that can do that on its own, right? And that just helps to ensure that the details it ends up adding in map to what you're trying to get out of it, right? So if we're asking it to add more detail when we scale it, then it needs to be able to like put the right detail in, right? And so that requires the model to be fine-tuned for that job. There are a couple of other upscalers that we're looking at that are pretty interesting, but we'll kind of share more about those updates as we get to them. I recognize that we're running out of time here, so I'll see if there are any final questions, and then we can go on our merry way and see you guys next time. Floor will be open for just another 10 seconds before I call it. And just, I do believe somebody asked, does the tile toggle have to be on? Yes, it has to be on if the image is large. If it's small, if you're doing a 2x, you can probably get away with it, right? So if this were a SD 1.5 and I was just generating a 2x or 1024 by 1024, I wouldn't need to turn on tiled. It's really about whether you're generating a very large image for that one piece. Okay, cool. Well, then thank you all for attending. Go have some fun with keyframes and control nets, and we'll see you next time. Take care, everybody. Bye.